This is Corey Drinkit, and we are going to talk about the high temperature sterilization. This is chapter 14. So we're going to explore the principles, the processes, and the practices that ensure safe and effective sterilization in the healthcare settings. High temperature sterilization, practically through steam, is the method of choice in most healthcare settings due to its proven effectiveness, reliability, and low cost. It works by using moist heat to apply thermal energy that can kill all forms of microorganisms, including spores. We talked about spores in chapter 4. So heat can actually kill those spores, and that's what we want. However, this method is only suitable for devices that can tolerate heat or moisture. When items cannot withstand these conditions, we can use other methods to sterilize certain instrumentation. So remember that sterilization is only effective if its items are properly cleaned and decontaminated beforehand. So cleaning eliminates visible debris, while decontamination reduces the microbial load, though not completely. So remember, cleaning and decontamination are two separate processes. When we clean something, we're just we're getting what we can see off the instrumentation first. So when it comes down from the OR to decontamination, when we hand clean it, we put it through the sink, we put it through the ultrasonic, we're hand cleaning that stuff. We're just getting what we can see off of the instrumentation. Decontamination occurs going through the washer disinfector. This is where it reaches very high temperatures to wash and clean, to wash and dry these instruments. So heat, the thermal, which is heat, will do the decontamination portion of it. So sterilization is the final step to ensure complete microbial destruction. So understand how the steam sterilizer functions. Its components and operation is essential for steam processing technicians. So this knowledge supports consistent sterilization outcomes and promotes patient safety by minimizing the risk of infection. So the factors. What factors affect the sterilization process? To ensure effective high temperature sterilization, there are several factors that must be controlled. Time. This is where the instruments must be exposed to the sterilant for the full validated cycle time. So when we talk about time, we're not talking about the whole time it takes for the whole load to run. No, we're talking about the time for it to be in the sterilization phase. So when we talk about a 4 and 30, we're talking about a 4-minute sterilization time and a 30-minute dry time. Or we might talk about a 10 and 45. We're talking about the 10-minute sterilization time and the 45-minute dry time. So the exposure time during that 4-minute or the 10-minute, the first number, that is the exposure time. So it must be exposed, those instruments must be exposed for that 4 to 10 or 10 minutes throughout the whole length to complete the for the sterilant to actually be effective. The temperature must achieve and maintain the target temperature, and that is usually between 250 and 275, depending on what device we are is in the autoclave, and that also depends on what system we are using too. Are we using a gravity or a prevac? Moisture. In steam sterilization, saturated steam is essential. Too much or too little moisture can compromise the results. If we have too much moisture, it's not going to dry effective. The moisture is going to hang on to those devices. If it's too little, it's going to be superheated. So there's going to be more cold air pockets throughout the sterilization phase, and that's what we don't want. Remember, the sterilant, the steam has to reach all parts of the device to achieve its effectiveness. Contact. Remember, we talked about, I believe it was in chapter 9, where we talked about wet contact time. Same thing with steam. The sterilant must come into direct contact with all surfaces, including the lumens and the hinges. So that first factor, the time, it's got to stay wet. The wet contact time is the moisture has to stay onto the device for those 4 or 10 minutes, whatever sterilization time we have it set. Air removal. So complete removal is necessary for effective penetration, especially in pre-vacuum sterilizers. And how do we load the load configuration? How do we load these the autoclaves? So instruments must be arranged to allow free circulation of the sterilant, avoiding overloading and improper packaging. So, and we also have to monitor all these variables to ensure proper sterilization and patient safety. The anatomy. This is important. We have to know what the anatomy of the sterilizer, what the components are used in the high temperature sterilization process. So the main one is the chamber. So this is the main area for item placement. It's surrounded by a steam-filled jacket to maintain the optimum conditions. So the chamber is the big portion of the autoclave. This is where we're putting the devices once when it's on the autoclave cart, that rack gets pushed into the chamber. So, and this chamber is surrounded by a jacket. The doors, the doors must be sealed securely to prevent pressure loss. They control the system. The control system automatic cycles to ensure precise operation. So the doors is also the weakest part of the autoclave. These autoclaves now, or these steam sterilizers these days, they're all automated. You push the button start. It closes the door. It locks the door automatically, and it starts the phase. Back in my day, when I start out, we actually had to turn a wheel to lock the door. You had to get that wheel tight, because if it wasn't tight, steam and air would escape out of that door and have a high-pitched sound. Along with the door, either on the door itself or on the outside of that chamber, there's a gasket. We got to make sure that gasket is intact as well. So you will look at that gasket to make sure there's no tears or rips. A clean, reliable steam supply is vital for effective sterilization. The valves and filters, they help maintain their air removal and steam quality. The drain line, which is at the bottom of the autoclave, it's usually towards the door. So if you look into the chamber on the floor, you'll see kind of like a little top. That comes out. That's your drain line. So the drain line removes unwanted materials, while gauges, sensors, and recording devices ensure that sterilization parameters are properly maintained and documented. We have to maintain and document everything that we do, especially in our sterilization phases. In sterile processing, there are three primary types of high temperature sterilizers used. One, we do use it, but not very often. This is the gravity displacement. This works by forcing steam into the chamber, pushing cooler air out through the drain. So these are simple but require longer exposure times due to less efficient air removal. So gravity displacement. Your hot air is being pumped in at the top back of the autoclave. So gravity takes over. The more of that saturated air comes in. It's forcing all the cooler air down and out of the drain. So gravity takes over. There's nothing helping it. So it's going to take longer to reach the correct temperature. It's going to take the exposure time a lot longer as well. The dynamic air removal sterilizers use either a vacuum pump or repeated steam flushes to remove air before the sterilization begins. So this is what most facilities use, is a dynamic air removal sterilizer. So just like the gravity, your steam is forced into the back portion of your upper back of your autoclave. It's pumping all that saturated steam in, but there's a pump in around the drain. It's pulling all that cooler air out, so it's forcing it in and out a lot quicker. So it's going to reach time a lot quicker. It's going to be less time for it to stay into that time phase. The immediate use steam sterilizers, or the IUSS. Back in my day, it was known as the flash sterilizers, but they changed the name about 10 plus years ago. So now it's known as the immediate use steam sterilizers, or the IUSS. So this is used only when instruments are needed urgently. They are sterilized unwrapped or semi-wrapped quickly, but are not recommended for routine sterilization due to a higher risk of contamination. So these sterilizers, now we have what's called a one tray. It's a container system used only for the IUSS. That's what it's made for. So if the instrumentation goes into these container systems, they're put into the IUSS. They're ran, but the parameters are completely different. They have a 4-minute sterilization cycle time, or a 10-minute sterilization cycle time. So that's the amount of exposure time it's got to meet, but it's only got a 1-minute dry time. So when it comes out of the IUSS, move to the sterile field, the scrub tech takes it out of the container system. It is still hot. It is wet. So that's the difference. And we should use these IUSS only in emergency times, to where we cannot process that instrument or that instrument set through the regular routine down in the department, to where it goes through our normal sterilization phase. The cycles. There are different phases and types of cycles used in high temperature sterilization. The process begins with the conditioning phase. So this is where air is removed to allow proper steam penetration. So when the steam is being forced into the autoclave, it's conditioning it. It's bringing it up to temperature. It's forcing the cooler air out. It's also taking all that cool air out of the pill packs, out of the instrument sets. It's taking all that cool air out as well. So it's conditioning it. It's bringing it up to the right temperature that we need. This can be done using either a gravity displacement or a pre-vacuum. So the next phase is your exposure phase. This is where the items are subjected to a saturated steam at high temperatures for a specific period to make sure we ensure the microbial destruction. So the temperatures are usually between 270 and 275, depends on what the manufacturer says. After the exposure phase, there is the exhaust phase. This is where steam is removed, and this is where the drying time begins. Pre-vacuum steam systems use a vacuum during this phase to improve drying, which is critical to maintaining the sterility. Each cycle must be monitored using a physical, a chemical, and biological indicators to confirm the sterilization parameters were met and the cycle was effective. So the physical monitoring of it, this is the receipt that is printed out throughout the whole phase. Once when it's done, it will finish printing it out. This will stay with the load itself. This is where you will check to make sure the exposure time was met. Make sure the temperature stayed at the constant temperature throughout the whole phases. You will sign this at the bottom of this receipt. This is a legal document. This stays with your documentation. The chemical portion of it. This is the internal indicators that we put in every package, in every set. In the pill packs, you will see the chemical indicator inside it. That should change. Once when it's in the pack, of course, you cannot see it, but it lets the end user know. Once when they open it up and they look into it, that's changed. They can use it. It went through the sterilization phase. The biological indicators is the ampoule that has the bacteria that we use to make sure that the autoclave is doing its job. That is done after the autoclave is done. You'll take that biological out, you'll crush it, and you'll incubate it to see if that cycle, if it killed that bacteria that's in that ampoule. If it has killed it, it's a negative result, which means it's a good cycle. If it failed, we have to document it that it failed and rerun that whole complete cycle. The conditions. So effective steam sterilization, also known as high temperature sterilization, relies on several critical parameters. First is the time. This ensures microorganisms are exposed long enough to be destroyed. So remember our time. Usually it's a 4-minute time phase or a 10-minute sterilization time phase. So when we're talking about time, we're talking about the sterilization time. How long does it stay in that sterilization cycle? The temperature must be within the validated sterilization range. So it's between the 250 to 275, depending on what type of sterilizer we are using. Remember, we talked about the moisture. Moisture is critical. So this is the form of saturated steam. It's essential because it transfers heat effectively. Direct contact. This is where the steam and all the surfaces of the items ensures consistent sterilization. Remember, that steam has to stay in direct contact with the devices for the allotted time, the allotted exposure time. So that 4-minute exposure time, that steam has to stay in contact with that device for those 4 minutes. After that, it's the air removal. This is removing air from the chamber, as trapped air prevents steam from reaching all the areas. And then the final phase, or the final condition, is the drying of the items after the sterilization. So this reduces the risk of contamination and preserves preserves the sterility. The quality and the moisture. Steam quality is crucial in high temperature sterilization. It's defined by the proportion of vapor to water. Optimal steam should be at least 97% vapor. Excessive water, which is over 3%, reduces the ability of steam to transfer heat effectively. That can also compromise the sterilization. Wet packs are a sign of poor steam quality or post-cycle condensation. So these packs are at risk for contamination and must be reprocessed. When it comes to wet packs, you usually will see it once when you pull the rack out of the autoclave, especially on your wrapped instrument sets or even in your pill packs. You'll see moisture. If it's in the pill pack, inside the pill pack will still have moisture droplets. On your wraps, on your blue wrappers, you might see droplets of water or condensation, or even a puddle. That's a wet pack. Depending on your facility, you should let your team lead or your supervisor know that you at least have one wet pack, because that could mean, depending on the facility. Usually, if it's more than one wet pack on the autoclave rack, we got to redo the whole rack. So we consider the whole cycle has to be redone. It's considered a wet pack. It's got to be documented as well in your computer system or on your record sheets or however you do your documentation. It must be documented that this load was considered a wet pack, a wet load, and it's been torn down and being reprocessed. Superheated steam. This is where steam is too dry and it cannot transfer heat effectively, which may result in the sterilization failure. So if it's way too dry, that steam's not going to come in contact with the devices during that contact time. And remember, we need that contact time. So if moisture's not on that items, then it's not getting it's not doing its job. So we don't like dry heat. We don't like super heated steam. So maintaining the right balance of steam and moisture ensures sterilization efficiency and the patient's safety. Proper loading and unloading of the steam sterilizer is crucial to ensure effective sterilization and to maintain the sterility of the items being processed. So during the loading portion of it, when you're on the sterilization portion of your in your facility, you're in charge of how that autoclave rack is being loaded up. So it's essential to arrange those packages so that steam can circulate freely, preventing any air pockets and ensuring the uniform of the sterilization. Items must be spaced correctly and not stacked tightly. So when you have pill packs, don't put a lot of pill packs to where they're packed in tightly. For your instrument sets, a good way, the way I was taught, and a good visualization aspect is if you can put your hand between your instrument sets and you can move your hand up and down, that's good enough space between your instrument sets. But always follow your manufacturer guidelines. When it comes to basins and basin sets or your graduate pitchers, make sure your basins and your basin sets are tilted to where the basins is going toward the bottom of the autoclave. We don't want moisture to collect into these basins. The pitchers or your graduates, make sure they're put upside down so that moisture is not collected. When unloading, you need to allow the sterilizer to depressurize completely before opening the door. For that, with that, after the cycle's done, you'll pull out the autoclave part. You still have to let it dry completely before you can even put stuff away. So the cleaning and the maintaining are crucial to ensure consistent, effective sterilization. So daily tasks including wiping down the door gasket. I talked about the door gasket a few slides beforehand. It's usually on the door itself or it's on the chamber. It's usually a gray or black. You just wipe it down. Make sure there's no tears or rips in it as well, because then air will leak out of it. It's a quick fix. Call maintenance, have them bring down another gasket, install it, and you're on your way. Nothing too drastic about that. Make sure you just wipe everything down with the lint-free cloth. The drain strainer, you need to clean that out to make sure there's nothing stuck into that drain, into that strainer, because if you use stamps, that stamp could come off. So sometimes it does happen. Locks come off and fall into that strainer. Me personally, every time I'm on the autoclaves, that's the first thing I check before I run a load. The book says it's every day. I like to say every shift, because you don't know if the person before you is doing that beforehand. Weekly or monthly tasks involve more in-depth procedures, such as running a chamber wash cycle, inspecting the door gasket for wear, and checking for leaks. Routine inspections help identify mechanical issues early, so it's important to ensure gauges, filters, valves, and traps are functioning as designed. Always follow the manufacturer's maintenance schedule and thoroughly document all cleaning and maintenance procedures. Properly report malfunctions to avoid compromising sterilization integrity. We do a lot of your facilities out there will do a preventive maintenance on all the autoclave, and that's usually a yearly thing. So they come out and check it every year, but it's also our job to make sure it's in working order too. So the objectives: discuss factors that just read the objectives. Make sure you understand what you are make sure you understand what you are reading. No right or wrong answers in these at all. So just make sure that you know what the objectives for this chapter consists of. And again, my name is Corey Drinkett. My phone number is listed. You can text me or call me. I advise you that if you text me, please put down your name first, because if you don't, I'm not going to respond. And then I will add you to my phone, so that the next time you text or call, I know who I'm talking to. This is my email address. It's Corey.Drinkett. It should be all lowercase. I made the mistake there. But it's Corey.Drinkett@FranciscanAlliance.org. Email me if you have any questions, please. And I thank you for your time in reviewing chapter 5 with me. And have a good night. Thank you. Bye.